Hello and welcome to the Dustin and Eric Podcast Show, brought to you by Mimosa Networks. Hello, I'm Dustin.
I'm Eric.
And today we're on episode number 3, Physical Network Planning and Design, where we'll talk about how to design your network and choose your equipment. Today we have a special guest with us, Tommy Polito.
Hey now.
Thanks for being here, Tommy.
Thanks for having me.
Tell us a little bit about what you do.
I am Mimosa's Inside Account Manager for the U.S. East Coast and much of Canada. I answer a lot of pre-sales questions, spec out projects, work with the channel, and work with my regional sales director and sales engineer, and help customers get up and running.
So potentially new WISPs who are watching these videos will talk to you first.
Very often.
Awesome. So moving on here, we're catching up to Dustin and Eric. So this weekend, I'm a huge reader, huge fantasy reader. Took a break from the book I'm reading, though, and actually went to check out some news sites instead.
News or new?
News.
Ooh.
You know, the fake news.
Ooh.
So, and then on Sunday, I took my wife to the San Francisco Zoo for the first time. I know she's been wanting to go for a while. Took a stroll around there. Takes a couple of hours at least to get around there, but they have tons of animals there.
Holy cow, that place is still open? God, I think it started over 140 years ago or something like that.
Oh, wow.
It's an old zoo. I think the tigers in there are like on their 30th or 40th generation. That's how long that zoo's been there.
That's quite a lot of tigers.
That's a lot of litter.
A lot of cat litter. Eric, what did you end up doing?
I worked in the backyard. I mowed the lawn in the backyard. I broke the gas cap off on the lawnmower, and so I had to repair that on the fly. I had an oily rag with a string, and I was tying that on there, and it's kind of hard to do because I had a cigarette in the left hand, and I got this rag in the right hand, and it all came out. The lawn looks marvelous.
Well, I'm glad that you are still alive and here with us today, Eric.
Thank you. That's capital M for marvelous.
All right, so moving on here.
And now it's time for the Interrogation Room, where we answer submitted questions from the audience. Number 1. How can I determine how many clients I should put on an AP?
So Mimosa clients and access points that they run on SRS can handle up to 44 clients, whereas Mimosa APs that are running Wi-Fi interop can technically handle up to 100. Tell me, what do you see out there?
Typically with my customers, I see them onboard anywhere from 10 to 30 subscribers per access point. That's a good oversubscription rate with the throughput that you have at that access point.
Excellent.
All right, number 2. Who do you use or have you used as a backbone provider?
So previously, I've used Windstream, which is more Midwest, but they're growing quickly. We had a 100 meg circuit through those guys, and then we started peering with a group in Chicago and had a gig circuit through Verizon. Found actually that the Windstream circuit was more reliable, although it was slower than the Verizon circuit, which kept going down at random times through the night and with little communication. So it comes back to last week's show where you should research your provider and check the reliability or the actual SLA agreement and find out if it's really the right fit for you and your customers, because even though it was more bandwidth, it was less reliable, so not as good for my customers. And then here at Mimosa, we actually use a mix of Hurricane Electric and Cogent, which we also talked about last week on the show.
All right, number 3. I found an abandoned tower in an area that I want to cover. What can I do to find out who is or was the owner so I can take care of it?
So most towers, when you go to the site, either on the fence or the building, there's a placard that has an FCC ID on it. Then you can pull up the FCC site and put that number in, and it pulls up all the information for that site, who owns it, and how long it's been there, and just everything that you need. Unfortunately, not every tower site is registered with the FCC, so another way to do that would be to put in the GPS coordinates and look for the land deed to see who actually has who owns that land, and you can go from there because the landowner usually knows who has a tower on their site. And can kind of point you in the right direction into who owned it or who does own the tower.
All right. 4. Should I find access point locations first in my neighborhood and then reach out to potential customers, or should I find customers first and try to look for access point locations afterwards?
So what I do is I look at our design tool or Google Earth, and try to identify some areas that I want to cover and look and see if there are any vertical assets in the area or rooftops that I can use. And once I do that, actually go out to the neighborhoods that I want to look at and actually look at the areas, because you can't tell from an overhead view if you can really cover those areas or not, or if there's any kind of obstructions in the way. And once I determine if I can, then I kind of start drumming up interest in the neighborhood. That way they kind of know that we're interested in their area. And then I, deploy the access point. Then I have, tons of customers waiting to be installed, already scheduled, ready to go. Giving the example of it is I went to a town to deploy internet service before I came here, and I found the vertical asset I was looking for, which is a water tower. I talked with the city and got permission to be on the water tower. So then I started walking through the neighborhoods, meeting people, putting door hangers out, drumming up the interest. We had over 100 people ready to go by the time I had the APs on the tower. So it's good to, we'll talk about this in another show about marketing, but it's good to get, your feet in the door before you start deploying your equipment. That way you can start pulling in, money as soon as possible, so your return on investment's much quicker that way.
So kind of go out, engineer or site survey first, get a feel for it, and then you reach out.
Right.
And also when identifying any site, you want to make sure that you can provide that site with your broadband. So ensuring that you can either do a backhaul to that site or it's fiber fed.
Excellent.
Oh, gotcha. Yeah. 5. Is 5 gigahertz affected by snow, rain fade, and storms?
So luckily at 5 gigahertz, you're not really affected by snow or rain fade much. It really depends on the length of your link and how heavy the rain or snow is, but even at longer distances, you might see a 1 or 2 dB fade on that, but it's really not going to hurt you that bad as long as your link is a decent link. Storms will not affect your link because of the rain or anything like that. It's more of power outages, lightning strikes directly to the equipment or nearby that might fry your Ethernet ports or the equipment itself if it's not properly grounded.
Oh, power. Maybe some ducting issues and such at the spectrum, the 5 gig spectrum. I think if you go up higher, you see 10, 11 gig, etc., then you start approaching having some rain scatter or some other stuff from adverse weather affecting that part of the spectrum. But down at 5 gig, we look at typical phenomena down there.
Right.
6, is 5 gigahertz harmful to humans?
There's no credible research out there that states that any kind of radio frequency that we're experiencing every day to be harmful. So that's the cell phones, satellite coming from orbit down to the Earth, 2.4 Wi-Fi, 5 gig Wi-Fi. None of that transmits at a high enough power to cause us any harm. And I would think that since we've been around radio frequencies for 60, 70, 80 years at least, that we would have seen something by now that would show that it's harmful. So at this point, no, it's not harmful to humans.
I think you have to go a lot further lower in the spectrum. Also, if you want to look at RF exposure safety, you can get some good information there about what's really happening at these levels, these common levels in the different parts of the radio spectrum.
Right. Yeah. Just make sure it's a credible source when you do that.
Yes.
All right. So moving on, today's main course is network planning and design. So your first thing is what are you trying to do? So you need to plan out your network. So let's say you have your tower site, you have your data center, but what is it you're really trying to do? Do you want to cover a subdivision? Do you want to cover businesses in town? Or do you want to cover that whole town? Luckily, Mimosa has a tool called the Design Tool, or Mimosa Design Tool, that will help you kind of plan your network out to help you determine if you can hit that area or cover that area or not. And you can do point-to-point links and point-to-multipoint links in this. So with point-to-point links, once you put the coordinates in for both ends for like your tower site and your data center, it'll show you if you have line of sight, Fresnel obstructions. It tells you how long the link is. It gives you the data for the SNR, the PHY rates, how much data that you can pass through that link. Or at least estimated, because again, you have to be able to see both ends of the link. And then with the design tool, you either have satellite view, which shows you the homes and the trees, or you have terrain view, which shows you more of the hills or any kind of ground obstructions you might have. Ultimately, though, it's not going to show you trees or buildings, so this is only kind of an estimate of what you're going to see.
So you still want to do those physical site surveys.
Right. And so with the point-to-multipoint planner, it will show you the estimated antenna coverage for whatever antenna you put in there. So we have our A5 and A5C with several different antenna choices. And then when you click on the actual map in one of the colored areas, it gives you information on what your signal strength might be with each type of radio that you might use at the other end, with data rates, distance, obstruction, etc. It's definitely something cool to go check out. Design.mimosa.co.
The pattern on the point-to-multipoint is great for when you're trying to plan out, is this a neighborhood I should go deploy in? Because it really gives you the ability to see where your target customers would be.
Right.
Your target customers would be within that splat pattern. So maybe those are people you should try to go market to.
But ultimately, we come back to you have to go out and actually site survey, because the design tool does not take into account tree coverage or buildings. It only takes in terrain. So you might go, hey, there's an area I can cover. The coverage shows great there. But then you come to it and see a giant building in the way, or it's just a grove of trees there that the design tool doesn't take into account. So physical site surveys are a must, regardless of what equipment you're using, or what vendor you want to use, or what tools. There's some tools out there that you have to pay a lot of money to even start taking into account those kinds of things.
I look at like for we go out on sites, and I look at like Fresnel obstruction, and I've got I think it's called RF Toolbox, an app for the phone, and it's neat. It kind of gives you an idea. Determines you determine link length, frequency, and it gives you a rough idea of the radius or the double radius for the overall Fresnel area for that part of the spectrum. So it's pretty handy.
The design tool is a great way to see if something's feasible first. So it doesn't replace doing that legwork, getting out there, doing a spectrum analysis, taking out some binoculars and looking at particular points you're trying to reach, just to ensure that you do have conditions that are right to deploy your radios.
Right. And one last thing on actually designing your network is trying to get relationships built up in your community that you want to cover with local co-ops or utilities, or other businesses, so you can use their rooftops or their towers or their utility poles or their light poles, so you can start building your network and covering more and more homes. The utility poles or the light poles will help you build up your Micropops a whole lot easier, help you cover so many more customers in neighborhoods where you can't get line of sight between your tower and the neighborhood you're trying to cover. So the point is to, shoot down to a pole, and then from there you can start going between poles and covering more folks that way. So try to leverage the people in your community and help them help you cover all of the homes in the neighborhood or in the whole community, depending on what you're trying to do.
Like in any business, partnerships help. So whether that partner is a local town, municipality, electric cooperative, or even say a building owner, getting that relationship where you're providing them a service and they're providing you access.
Yep.
Right. So moving on here to why should you use Mimosa? So Mimosa radios are very affordable. The megabit per dollar spent is very cost effective. Mimosa radios are also very reliable, but if you do have issues, we have in-house chat and phone support along with a very detailed support site. It's not something we outsource to, India or anything like that you might get from a huge company like if you're calling Apple. So it's local folks that are really interested in helping you get your network running like it should be if it's not. Mimosa also has different frequency options ranging from 5 gig to 10 and 11 gig all the way up to 24 gigahertz depending on which products you want to use. But most importantly, Mimosa loves you. And so we're moving here into our high reliability backhauls, which they can do over 1 gigabit of connectivity, depending on how you have your radios configured. We have integrated solutions and we have connectorized solutions. So the B5 and the B24 are both integrated, so they're better for shorter distances because you can't put larger antennas on them. The B5C and the B11 are both connectorized, so you can put different size dishes on them to increase distance or help mitigate interference depending on what you're trying to do in your setup.
Yep, exactly. Why we compare these radios, with each other is really they share a lot of the same feature sets. They can both operate on single or dual 20, 40, or 80 meg channels. They're both capable of moving over a gig, and they all have the GPS synchronization, so you can co-locate multiple radios at the same site.
Excellent. And then our next set is our cost-effective backhauls, which are 500 plus megabits, depending on how they're set up. So we have the B5 Lite, which is an integrated solution. Again, it's good for shorter range distances because you can't increase the antenna size of it. Then you have the C5C, which is a connectorized radio. You can put a bigger dish on it. Again, it's similar to the other radios where the bigger the dish, the further you can go, or the more interference you can mitigate.
Exactly. So these are great options for maybe doing a backhaul on the edge of your network, or if you have a dedicated business customer who needs a point-to-point link. For example, the B5 Lite list price $300 for a wireless bridge kit and can do up to 750 megs. So it's tough to find another radio on the market that really competes with that price point and throughput.
Right. So it's really easy to deploy something like this to get a network going, and then later on down the road you can upgrade to a bigger backhaul if you need to. So it's perfect to get the edge network going, and then once you start pulling in money, you can start building it up if you need to. And then we're moving in here to our access points. We have the A5, which is an integrated solution, A5C, which is a connectorized solution. So the A5 is good for a short range deployment like Micropops we were talking about earlier. It's meant to go on a rooftop that's similar height to all its rooftops you're wanting to hit. The A5C is meant more for a tower deployment where you put a sector antenna on it and you have clients out to about 20 kilometers or 12 miles depending on how your network is, how you want to set your network up.
100%. Both these radios, just like on the backhaul, they share a lot of the same features. So they're both capable of a gigabit. They both have the GPS synchronization. The application is really the difference between the two radios.
All right. And then our client radios, we have the C5 and the C5C. Again, it's pretty similar to what we've already talked about. The C5's integrated solution. So it's good for short range installations. When it's connected to the A5, you know, we say 300 to 500 meters. Was connected to an A5C with a sector, you know, up to maybe 2 miles. It really depends on what data rates you're looking at, what kind of service you want to provide to your customers. Whereas the C5C, you can put, you know, smaller or larger antennas on it to go the further distances to pick up the more remote clients. It comes back to what kind of network you're wanting to build, what you're trying to do with it. So you need to plan out your network so you know kind of what equipment you need to buy.
100%. So once again, these radios share the same specs. The difference being is we give you a connectorized option. So the ISP can go out and pick a antenna depending on the deployment as needed. If not, the C5 is a great small footprint, integrated slant 20 dBi dish. So it works great on the closer to mid-range.
Okay, so the cool thing about these radios is that you can go up to 6.2 gigahertz too. A lot of places in the world you can use this spectrum and it's underutilized. There's a lot of people out there who need the cleaner spectrum to deploy on, so these are really attractive to those guys as well.
In addition, these also work down in the 4.9 public safety band. So if you're a municipality or maybe you're helping a municipality offload some of their broadband restraints, you can use that center of the frequency as well. Excellent.
So now we're going to talk a little bit about Micropops. So they're more of your short range deployments. The access point, the A514, would go on a rooftop, and then all your other rooftops would be about similar heights. And for the real short range, you would use the C5, and for a little bit farther out, you would use possibly the C5C with a small antenna, or it just depends on the customer and if they'll allow you to use a larger antenna or not. It just depends on your deployment and what you're trying to do and what your customers will allow.
So typically when customers ask me about the range of a Micropop, I say it's a sub-kilometer type deployment. And the reason being is you're usually closer to the ground. You're on top of maybe a two-story home, a utility pole, a light post, 20, 30, 40, 50 feet up in the air. You're typically not going to have line of sight miles out. So in this scenario, deployments like suburban neighborhoods, subdivision, campground, I've even seen marina deployments. Yep. These are all great applications for the Micropop. In addition, it has the GPS synchronization. So if you have multiple pops that could potentially see each other, you're using that synchronization so you're not stepping each other on yourself with interference.
We have a campground site that's like that. So maybe no taller than one story building for the access points. GPS is cooking. We got 30 plus clients on board, and yeah, it works out neat. Very nice little test site.
Right. So we have like 6 or 7 different A5s out there that are, relatively close to each other. So we're testing GPS synchronization, and we have the bungalow tents that are hooked up with C5s, so we can test the GPS synchronization, the co-location of the A5s to make sure everything works. And at the same time, we provide the guys that are people that are there with internet service as well. So
interaction with dual back-to-back sectors at one spot as well.
Yeah. And to add why the A5 does Micropops so well is really its footprint. It's about the size of a coffee can, so aesthetically it's very pleasing. If it's on a resident's home, if it's on a utility pole, it's not a big, massive radio that can really be noticed.
Right.
Tiny deployment. So.
All right, and then we go into our tower deployments where people deploy on radio towers or water towers, and they're trying to get people that are a little bit further out usually. These are the guys that have line of sight, or you're in like the Midwest where you don't have a whole lot of trees, or you just have homes or buildings or businesses that you can see from the towers. And so up close C5s are still good for this, but it's mainly built for C5Cs with connectorized antennas, flat panel antennas, or parabolic dishes, or even reflector dishes, depending on which vendor you use. And so it's meant to pick up those guys that don't have any service or underserved. You want to give them decent speeds, 100 megabit speeds, 50 megabit speeds, whatever you're trying to serve your community or the customers you're trying to cover.
Yeah, and just to talk about range with the A5C in tower deployments, we say ideal conditions, maybe you're going out about 20 kilometers. We got some guys in Montana who are probably doing that where it's kind of wide open terrain, line of sight. They have the high assets to really cover that terrain. But typically in different areas, I see guys going anywhere 5, 6, 7, 8 miles.
Yeah, we've got a system like that, a test system like that with maybe a dozen folks on board, C5Cs, little 30 dB dishes pointed back 5 miles to the access point. And we got a little elevation at the access point, but the challenge was multiple ridges in the way. So again, the surveys on the site from each client's side pointed back towards the access point was important, but that seems to be working really well.
And in addition, with the A5C and the tower deployment, you are trying to maximize the amount of radios you can put up there, so you can maximize the amount of subscribers you can support at that site. That's where the spectrum reuse synchronization comes into play as well with the A5C, where back-to-back radios you're sharing same center frequencies.
Right. And so we also have another A5C in the same area that Eric was just talking about with 28 clients on it, and we're reliably providing 100 megabit up and down speed to all of those clients as well. So again, it's kind of in Tommy's range earlier of between 10 and 30 clients to give them reliable service. But you can still push it up to the max of 44 and still reliably provide 80 up, 80 down. It depends on, again, on the speed package you want to sell, the distances. There's a lot of factors in play here that you just have to plan around before you actually deploy, so you know more what to expect once you have.
Yep, the oversubscription rate that you're comfortable with and the commitment that you want to offer your subscribers.
All right. And so moving here to Tech Tip of the Week.
Tech Tip of the Week, brought to you by Hummeken. Amsterdam never tasted so good.
All right, so this week's tech tip is...
When deploying any Mimosa radio, you should use the dielectric grease that comes in the box. This grease helps protect the Ethernet port and the cable end from moisture and spiders.
All right, so excellent tech tip. And so that's the end of our show. So let's just recap real quick what we talked about. We talked about physical network planning and design, so planning your network, building your networks in the design tool so you can kind of estimate what you're trying to do. Then you need to go out and actually survey the area to make sure that you can actually cover those people or businesses, whatever you're trying to do. And then we talked about leveraging your local co-ops and other guys so you can get on towers or rooftops, utility poles, light poles, just anything to get, free or reduced cost assets that you can deploy on. And then we talked about why you should choose Mimosa, and we kind of covered our backhaul and our access equipment, client equipment, and talked a little bit about our Minipops, Micropops, and tower deployments.
Megabits per dollar.
Megabits per dollar.
Mm-hmm.
And so next week we're going to be talking about actually internal networking, connecting the dots. So we'll have a little bit about routing and routing protocols and what you should use, what you shouldn't use. And we'll have a special guest next week who actually is a WISP who will talk a little bit about how their network is set up. And so we hope to see you next time on our next show. Thanks for coming, everybody.
Thank you, Tommy.
Thanks for having me.
Thanks for tuning in. Please hit the subscribe or follow button to stay up to date with our latest podcast, which will be available on YouTube, iTunes, Google Play, and SoundCloud.